This is the first video in a three-part series demonstrating the process of lost wax metal casting using the Cera-Fusion ceramic shell system. This video will provide an overview of preparing a wax model. The foundation of our metal casting process begins with wax. For ceramic shell metal casting, it is desirable to have a hard wax that provides clean carving and low shrinkage. Low shrinkage is particularly important when it comes to melting the wax out of the ceramic shell. As the wax heats up, it expands, often with significant force. This force can crack the ceramic shell before the wax has reached its melting point, certainly not ideal. We've tried many different combinations of wax blends. Ultimately, we developed our own blend of several waxes that has low expansion and shrinkage characteristics. To demonstrate the difference between a typical carving wax blend and Castable's LSR wax, I'm pouring a block of each wax type in the silicon mold. After cooling down to room temperature, the carving wax blend has sunken in the middle, whereas the Castable's LSR wax has a flat top. Placing a ruler on top of these samples highlights the difference. You can purchase blocks of Castable's LSR wax on our website. You can also purchase wax molds from our website. To create my wax model, I'm using a 3D printed mold. To prepare the mold, first it's wiped down with a cloth to remove any dust or loose wax from the previous use. Next, Stoner urethane mold release is applied. This will make removing the wax model much easier later. The wax is melted in an electric pan and then poured into the mold. The mold is then left for a couple of hours to allow the wax to harden. You may notice a small crack in the web of this model. This isn't uncommon when using a rigid mold like I am here. However, this is an easy fix that we'll address later. To complete my wax model, I also have made a cup and a few wax rods. Next, I use wax and grease remover to clean off the mold release agent. This step is very important to ensure strong welds between wax components later in the process. When it comes to wax carving tools, this is the 4 tools I most commonly use during assembly. A flat and round scraper, a spoon for transferring molten wax, and a small blade to get into tight areas. I also have a soldering iron with a blade tip. This is heated to about 160 Celsius and is used for cutting and welding. Lastly, I have a hot air rework gun, which is commonly used for electronic PCB work, but it makes for a very good precision hot air gun for smoothing wax. Let's take a moment to explain how I'm going to assemble my wax model. First, I need to consider what orientation I will have the wax model in at the time of pouring. For this model, I'll have the base facing up. I'll add a cup to the base, which will make pouring metal much easier and safer. Next, I need to add a separate path for air to escape the mold as it fills with metal. Since this area of the model is also an undercut that will trap air, I'll add a riser at this point. The riser attaches to the side of the cup, which then returns any molten metal back to the cup. To support and add strength to the riser, I'll attach a sprue between these 2 points. First, I'll run my blade along the crack to heal it. Then I'll add a small amount of wax to level the surface. Then I'll use my small blade to clean up the surface. Now I need to attach the cup to the base of the wax model. First, both surfaces are flattened and smoothed on the hot pan. Next, both pieces are heated simultaneously and then quickly pressed together to create a strong bond. After cooling for 5 minutes, I use my soldering iron to melt the two edges together to guarantee a strong weld. Next, I pick up wax using my iron and use it to fillet the connection between the two components. With that done, I move on to adding a riser. With the riser finished, I use my scraper tools to smooth the surface. This is an important step and should not be overlooked. Having a model with smooth surfaces and joints helps the metal to flow smoothly throughout the mold, producing a higher quality finish in the end product. And this is what the complete wax model looks like. Before I move on, I'm going to weigh the wax model. Later, I will reference the wax model's weight to calculate the quantity of metal required to fill the shell. Since this is a relatively small model, I have the option of adding a handle and dipping the model into the slurry. I'll weld this block of wax to the base of the cup, which will make up my handle. To guarantee the handle doesn't break off prematurely, I'll screw the handle to the base of the cup. In the next video, we will cover how the ceramic shell slurry is applied to the wax model.